Good morning and welcome to today's Electronic Design webcast. Our topic today, SPE and the Future of Industrial Networking, sponsored by TTI and Phoenix Contact. I'm Bill Wong, Senior Content Director with Endeavor's Design and Engineering Group. To begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, simply type your issue into the Ask a Question box, and a member of our team will assist you. You can also click on the question mark Help button in the upper right corner of the screen. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your question into the Ask a Question box and click on the Send button. If you would like a copy of the presentation, please click on the Event Resources on the side of your screen to download the presentation. Also, please be aware that today's session is being recorded and will be available on the Electronic Design website within the next week. You'll be notified by email when the archive is available. Now let's meet today's speaker. Guadalupe Chalas is the Senior Marketing Data Specialist for Phoenix Contact. Now let me turn things over to our presenter. Guadalupe, the floor is yours.
Welcome to the TTI SPE webinar. My name is Guadalupe Chalas, and I am a Senior Marketing Data Specialist for device connectors at Phoenix Contact. I joined Phoenix Contact with 7 years experience in high-speed interconnects, 5 of which I spent as a product development engineer designing high-speed connectors and specializing in single-pair Ethernet for automotive infotainment applications. And for that, I hold 3 patents. More recently, I have worked in product management and product marketing, focusing on device connectivity for industrial applications. At Phoenix Contact, I am a senior specialist and subject matter expert of sorts for the device connectors division with an emphasis on data products. And my goal is to consolidate Phoenix Contact's narrative on data as we become a leader for data connectivity solutions. I do hold a bachelor's degree in mechanical engineering from Penn State University. Okay, today I'm going to be doing a presentation on SPE, and like the title says, TTI SPE presentation. And the reason for doing this is because, one, we have a line of products that conform to the single pair Ethernet standards, but 2, because application areas are beginning to transition to Ethernet protocols and field devices continue to require more transmission capabilities. SPE has the advantage to deliver both fast and gigabit Ethernet combined with power over a single 2-wire interface. This makes it easier to implement Ethernet from the field to the cloud. We already see end users, vendors, system integrators, and component manufacturers come together to publish specifications that address SPE implementations for their specific market areas. Such collaborations and partnerships highlight the importance of single-pair Ethernet for industrial applications. SPE has the advantage to enable high-speed communications over a single pair and allows for the use of standard industrial-grade housings proven to withstand the harshest environments, making it the ideal upgrade for both low-speed and high-speed protocols with a single connector interface. While single-pair Ethernet promises to revolutionize the industrial markets with speeds up to 1 gigabit per second over a single pair, there are still questions surrounding standardization and the benefits of SPE when compared to industrial RJ45 and other standard products. It is important for system integrators and component manufacturers looking to implement SPE in the near future to learn about the different variants and what solutions are and will be available to them as they transition and upgrade current systems to SPE. The topics of discussion today include an overview of single-pair Ethernet and a walkthrough through the standards that are available to us today. After that, we will go into some of the benefits of SPE, and we will conclude with the product offerings from Phoenix Contact. What is single pair Ethernet? Single pair Ethernet is a miniaturized two-wire Ethernet solution that enables direct connectivity and power delivery to field devices. Today's industrial Ethernet infrastructure is effective but has its limitations. Ethernet, created as a non-standardized software protocol in the 1970s for internal and local transmission of data packets, is something that everyone recognizes as the common standard for accessing the internet. Internet is also used for factory, building, and process automation applications. And for this type of application, we use industrial Ethernet, which varies from standard Ethernet, in which industrial Ethernet allows for deterministic and real-time data exchange. Why does it have limitations? As you can see in the image on the right-hand side, we do have Ethernet in the enterprise, work center, station, and control device levels. But when it comes to the field device level, we don't have Ethernet. We use a gateway to connect us to other protocols, such as IO-Link, Profibus, CAN bus, etc. These are protocols that have been used for years and in the past had allowed us to communicate from the device to the control device. Now, why does it have limitations? Well, because the Ethernet connectivity is not seamless. It's not seamless. It can be delayed. So the hope is that for the future we can eliminate the gateway and not require that bridge between field buses and Ethernet networks. The future of industrial Ethernet infrastructure with SPE looks a little different than what we saw in the previous slide. Now we don't have a gateway and we have Ethernet going all the way to the field devices. This allows for an increase in efficiency, which in turn produces fewer downtime instances and shorter downtime durations. It also allows for smarter devices because of increased communications to the devices, meaning you can collect data from a device and tell a device exactly what to do at the same time. Also real-time manufacturing data, which allows for cloud computing and increased analysis, and then overall higher capabilities because you can get much higher data speeds than with protocols previously used at the field device level. And last but not least, greater cabling distance at lower speeds because single pair Ethernet enables up to 10 megabits per second over a distance of 1 kilometer, which is much longer than what we have seen with any other protocol. So what are the differences between industrial Ethernet and single pair Ethernet? This is a question that we get all the time. For starters, single pair Ethernet is Ethernet over a single pair of wires. And I have that diagram on the right-hand side showing different kinds of Ethernet. So the first one, or the 100 base TX, is what we call fast Ethernet, so between 10 and 100, although 10 base TX is obsolete now. The second one is gigabit Ethernet, 1 gigabit to 10 gigabit, and then the third one is single pair Ethernet, and that it actually includes a lot more than one speed. It has a 10 base T1S, which is for short distances, 10 base T1L for long distances, that's the one that goes to 1 kilometer, 100 base T1 and 1000 base T1, which is gigabit single pair Ethernet. So going back to the differences, we have our fast Ethernet historically has been half duplex, meaning you need one pair of wires to transmit, one pair of wires to receive. When it comes to gigabit Ethernet, now we are doing the transmit and receive over a single pair, but you need 4 pairs because of the much higher speeds. For single pair Ethernet, we are doing all of that over one single pair. And we are also using, adding power capabilities. And what this means is that we just have reduced cabling for single pair Ethernet when compared to the other Ethernets. So that's kind of the main difference between the two. Now, why is it important? The cabling, the reduced cabling, and the reduced footprint as well that you will require for implementing this design into your application. Another thing that is different between industrial Ethernet and single pair Ethernet is that single pair Ethernet can support multiple nodes. So the 10 base T1S version can support up to 8 nodes or drops. And currently there is work being done to improve that to 16 or 32 nodes. So those are the main differences. So when you look at industrial Ethernet and single pair Ethernet, the footprint is much smaller for single pair Ethernet, and that's just because we are using much less wire, just 2 contacts as opposed to 4 or 8 contacts. So now let's talk about the power aspect of single pair Ethernet, which is PoDL, or power over data line. And PoDL enables both power and data over a single pair of cables. Now we usually get the question of what's the difference between PoDL and PoE. And PoE is widely recognized because it's the way of Ethernet or industrial Ethernet and power. So the differences are as follows. PoE requires at least 2 pairs of wires. It's effective, but it adds cost, weight, and size. PoDL requires only 1 pair, so reduction in cable requirements, size, weight, and cost. PoE has different power classes and provides between 15.4 watts and 71 watts of power for PoE++. PoDL, on the other hand, has 10 power classes, and it ranges from 0.5 watts to 50 watts at the power device. For the different types of single pair Ethernet, especially the 10 megabit per second one, the short reach, which is 15 meters, will give you up to 50 watts of power. The long reach, about 1,000 meters, will allow for about 7.7 watts of power. So Phoenix Contact has a range of products to address single pair Ethernet. But we didn't just go out on our own and design these products. We actually took part, or are taking part, on a system alliance. And it's a partner alliance that includes all levels of the industrial Ethernet ecosystem. And it's geared towards the ease of implementation from the sensor to the cloud. And as you can see, we have a list of manufacturers that we have partnered with to come up with a solution, and we do have a website as well. It's singlepairethernet.com, and you can go visit and see what we've been doing with single pair Ethernet, and also any events that might be coming. Now let's talk a little bit about standards, because it's important to know who is doing what when it comes to standardization. At the top level, we have IEEE, which defines the requirements for Ethernet transmission. Then in the middle, we have ISO or IEC, defining the requirements for the transmission channel for SPE specifically. And then at the bottom, we have industrial Ethernet user organizations, which define the requirements for application-specific transmission and cabling. Now, for us, here today, we are going to expand on IEC 63171, which defines the requirements of the connectors, because we're talking about the connector. So when we look at IEEE, the Institute of Electrical and Electronic Engineers, we have several committees that address Ethernet. At the top level, we have IEEE 802, and that addresses local area network and metropolitan area network standards. And that's an umbrella for pretty much all Ethernet standards. Then we have subcommittees within that, and that's the 803.3, and it's just for Ethernet. And then when we look at under the umbrella of 802.3, we have 802.3xx. And these are working groups that work to release specific Ethernet standards. Now, for single pair Ethernet, we have a few. We have a standard for power over data line or power over Ethernet over 2 wires, which is CQ. We also have a physical layer specification for 10 megabits per second operation and power, which is 802.3CG. And last but not least, there's a working group right now working on 10 megabit per second single pair multi-drop, and that's 802.3D8, and that's the one I mentioned earlier or made reference to earlier when I said that there's some work in expanding the multi-drop capabilities from 8 nodes to 16 nodes, and that's what this group is doing. Now, when it comes to connector interface standards, that is strictly IEC. So IEEE does not establish connector interface standards for single pair Ethernet. IEC does that, the International Electrotechnical Commission. And when we look at the IEC standards, we have a few for single pair Ethernet, and they are geared towards different applications. So they didn't just come about to overlap. They are all geared towards different applications. For example, at Phoenix Contact, we are working on 3 of those standards. One is the -2, which is on the 3rd column, and that is an IP20 connector, rectangular, for industrial applications that don't need to be waterproof or sealed. We have a -5, which is same interface, but within an M8 or an M12 housing. And last but not least, we have a -7, which is the latest one, and for that we have a partnership with TE Connectivity, and that is M12 plus power. So we're going to have 5 different power classes, and it's going to be IP67, and that is going to be released next year. So let's dive a little bit into the benefits of the -2 and the -5, for which we already have parts on hand and available. So when it comes to the -2 and the -5, one of the main benefits is miniaturization and ease of integration. Miniaturization is a big one for us. As you can see on the right hand side, the interface of the SPE connector is way smaller than a standard RJ45. So you can get up to double the packing density of an SPE where you had an RJ45 in the past. It also offers the smallest interface for the entire series of standards, which is a great thing if you're looking for miniaturization again. The other benefit with miniaturization is that it can be integrated in a standard M8 housing and connector, and the -2 and the -5 have the same internal interface as well. One of the good things about this is that up till now we haven't been able to get gigabit Ethernet within a M8 interface, because as mentioned before, gigabit Ethernet is 8 wires. M8 doesn't allow for that. So this gives us the opportunity to have a gigabit Ethernet solution within one of the smaller M interfaces out there. One thing to keep in mind is that many sensors are built with an M8 connection thread, and we have the only SPE IC67 interface on a true M8 thread size, which simplifies the integration of SPE into standard sensor designs. Another benefit of SPE that shouldn't be overlooked is its industrial reliability. SPE is mechanically robust, is safe against vibration, it provides EMC compatibility, and it is very safe in industrial environments. SPE has been tested for a wide range of mechanical and electrical performance criteria, and it can meet up to 750 mating cycles. It has the same vibration standards as RJ45, M8, and M12. It's got optimal shielding connection due to 4 grounding legs, and it has overvoltage protection up to 2.25 kilovolts. Another benefit of SPE is that it's future-proof. Supports up to 1 gigabit per second over a 40-meter distance in 10 megabit per second over 1 kilometer. Profinet maximum reach is 100 meters at 100 megabits per second. And IO-Link maximum reach is 20 meters. So it just shows that it provides a lot more speed over much longer distances. It also includes broad technology competence from leading companies coming together, representing key markets, and coming up with a solution that fits and that works for everyone. And it also has M8 compatibility, which allows for easy integration and installation within existing systems. And just to show you, here's an example on how to ideally connect a sensor to the Ethernet. Instead of having a gateway, you would have your sensor with your M8 thread, and you would have SPE in there. Then you have a single cable going to the switch. Seamless Ethernet. Your cable has 2 wires for data and power, and you can get all of your services through that single cable with a compact connector for all industrial applications. Before I take you through the offerings that we have, I just want to take a time to show you the design to cost of RJ45 versus SPE, because one of the questions I get all the time is how does the pricing compare? And yes, right now, today, SPE will be more expensive because we don't have the volumes. But as you look at this graph and we go into the next few years, the average market price of a 1 meter SPE patch cable will be much lower than the average market price of an RJ45 patch cable. Again, we are reducing cabling. We are using 1 pair instead of 2 or 4 pairs, so we are reducing copper by a lot. And that actually will take us into the future with a more cost-effective solution. As far as product availability for IP20 products, we have PCB connectors and network or patch cables. For the PCBs, we have a straight connector or 180 degrees, and then we have 2 90-degree connectors, one with LED. On the IP67 side, we have a few different options with different soldering processes in different angles as well. So we have the 180 THR, 180 SMD, 90-degree THR, and then we have our network cables, M8, and one for lower speeds, the one for 20 megahertz is for the lower speeds, and then the one at 600 megahertz is for the gigabit Ethernet or applications. When it comes to switches, we have test installation together with sensors and device manufacturers, and we are ensuring interoperability of SPE and PoDL. That's what we're doing right now. Now we are looking to launch our first devices in 2022 and continue to expand the portfolio based on market needs also in 2022. For more information, visit Phoenix Contact Data Solutions on the TTI website, and also the Phoenix Contact Single Pair Ethernet page also on the TTI website. Thanks to all of you for taking the time to participate or listen into this webinar, and now we'll go forward and answer any questions that you may have.
Great. Well, a few of you have already submitted questions, so we're going to jump right in. If you'd like to submit a question, type your question into the Ask a Question box and hit Send button. Also, please take a moment to complete the feedback form, which will appear on your screen at the end of the webinar. So to start with, is there a move to add transformer isolation for the 10-base T1L to any of the standards?
Right now, Oh, there's a lot of feedback here. Right now, it's not in the works, at least for us. I do know that that's very important when it comes to RJ45 and having integrated magnetics. With SPE, it might be a little different because of the miniaturization in the size, the footprint of the connector, but I'm certainly sure that in the future it's something that we will explore as well. But from the standard side, it's not something that it's been added to the standards as of yet.
Okay. Do you know if there's any work on 100 or 1000 base T1 industrial, non-automotive applications, possibly looking at longer distances?
That is certainly something that we are always exploring and looking to see what the maximum reach. I know at least for the base T1, we've been playing with distances up to 1,200 meters or 1.2 kilometers. For the higher speeds, it's something also that has been bounced around, especially within IEEE, but it's not near completion yet. So we cannot yet specify any longer distances for those two.
Okay. Do you know if there's a hub that can convert the RJ45 Ethernet to SPE?
That is one thing that we at Phoenix Contact are definitely working on. It would be a switch that can take RJ45 and also up to 8 SPE ports, and it would also deliver power as well with a PoDL class 12, which is 36 volts for the power sourcing equipment and giving up to 20 volts to the power device. So yes, and that product will be on the market likely middle of next year, so end of Q2 2022.
Okay. What is the rated wire size for SPE?
So right now for the products we have on the market, the samples and the patch cables, it's 22 gauge wire, so that's what we terminated with.
Okay. Is there a sample kit available?
Yes, we do have sample kits available for our customers. You can definitely procure them online from going to phoenixcontact.com, or you can reach out. I'm not sure if you'll have my contact info, but I can definitely help. We can definitely help you with that.
Okay, here's an application-oriented question. Could you comment on the applicability of SPE with regards to alarm management?
Certainly not an application that we have been looking into right now, but thanks for bringing it up. We'll probably look into that a little more.
Okay. What is the advantage of IEC2 versus IEC6?
So the advantages. So the IEC-2 is unsealed, and it's an IP20, and it's mostly for unsealed industrial applications. The -6 is more it's the same interface as the -2, except it's in an M8 housing. So advantages, environmentally, you'll get more protection with a -6, but internally they are the same interface internally.
All right. Could you cite some use cases where this technology has been successfully deployed?
So I think that the main case here that we can look into, and we look back into, is automotive. So when it comes to industrial, we don't necessarily have the we don't have the applications or the implementation yet because we don't have PHYs readily available or we don't have the switches. But when it comes to automotive, it's been around for a while. I personally worked in designing automotive connectors for these products, and it has been very successful. So if you want to look at use cases, I would direct you to automotive and how they have been able to reduce cabling and get much higher speeds into vehicles just by using single pair Ethernet.
Okay. What about PHYs? Are there any PHYs for SPE available on the market?
Yes, so there are manufacturers already out there, such as TTI and Microchip, who already have PHYs available for testing these solutions, and they have them available through certain distributors, so you can reach out to them. So it can definitely be tested in your application as of now, really.
Okay. More application-oriented questions. What about solutions for process automation, especially for intrinsically safe applications?
So for that, there's aside from the work that we've been doing with IEC, we've also been working on something called the applied physical layer, and that is more geared towards process automation. So it's a different approach to single pair Ethernet using standard terminal blocks, and it will definitely address the intrinsic safety aspect of those applications. So definitely something to keep in mind as we move towards the future.
With wireless capabilities expanding, why the push for a hardwired interconnect such as SPE?
So definitely, I mean, wireless definitely has its pros, but these wireless applications don't fit every, or wireless solutions don't fit every application. So when it comes to Ethernet or wired connectivity, we do get more security. We get additional noise immunity. Initially, probably a better cost, especially now that wireless is not widely available. Higher data transfer rates, and last but not least, power. So wireless definitely has its place, and there are trade-offs. But Ethernet is a standardized protocol across many industries, and it's much easier to implement, especially if you can use existing wiring infrastructure. So that's why we continue to push on hardwired interconnects.
Well, I'm afraid we've run out of time. For those questions we didn't get to, we'll be getting back to you via email. This concludes today's presentation. On behalf of Electronic Design, I'd like to thank TTI and Phoenix Contact for sponsoring today's event, and of course to all of you for joining us. Have a great rest of the day.